Hello guys, we have already discussed about some basic of graph concept and also DFS and BFS algorithm. So the for practice purpose, in continuous 2 or 3 lecture, we will discuss about problems related with DFS and BFS. In this video, I am including one lead code problem number of provinces, okay, or number of provinces. This problem is similar to the similar problem of number of connected component which is on GFT website. Okay, so number of provinces and number of connected component, both problems is same. So let's understand what is the actually problem. There are n cities, some of them are connected while some are not. If city A is directly connected with B and B is directly connected with C, then we can say that A is indirectly connected with C. Okay, a province is a group of direct or indirectly connected city and no other city outside of the group. We are given an correlation matrix is connected where if each connected matrix value is 1, that means ith city and jth city are directly connected, and if each connected ij equals to 0, showing that there is no direct connection between city I and city j. Okay, so let's understand what is the what is the problem. Okay, for understanding problem I'm going to discuss with one example. We can take same example 1 and 2, 1 2 3, but this is the simple example, so maybe not understanding. Okay, this problem, to understand this problem clearly, I want to take one example. For naming purpose, this is 0 1 2 3 4 4 5 6 7 7 and 8. These are the vertices. Okay, and these are is 0 1 1 3 2 0 and 2 3. Here 0 1 2 and 3 is one connected component, 4 5 6 is another connected component, and 7 8 is another connected component. So the total number of connected component or total number of provinces here is 3. How can or why you cannot say that this component or this component is same? This connected component or this connected component is different because the meaning of connected component is that if you are at 0 node, okay, then inside this connected component we can go at any vertex from 0. That means if you are at 0, then you can go at 1, at vertex 2, and also at vertex 3, either 0 2 3 or 0 1 3. Okay, but that means 0 1 2 3 all is inside same connected component. If you try to go from 0 to 4, you are unable to go. Okay, so you can't go from 0 to 4. So this 0 and this 4 is not inside one connected component. That means this 4, if you cannot go from 0 to 4, so this 4 will be another connected component, but this 4 vertex will be inside another connected component. So this is one connected component and this is the another different connected component. Similarly 7 it is the another connected component, because from 0 1 or from 4 we cannot go at vertex 7 and 8, but at if you are at vertex 7 we can go towards the vertex 8. So this 7 8 it is inside one connected component. So the total number of connected component here is 3. But how how is it possible to obtain the solution for this problem? Some basic or let's simple example or simple concept. If you are at 0, if you are at 0, you will try for neighbor of 0, that means you call for 1. In this video I will approaching via DFS. Okay, so if you are at 0, you will call for one neighbor, and 1 is unvisited, so you will call 1. If you are at 1, you will call for 0, that means neighbor 0 and 2, 0 and 3, but 0 is already visited, so you cannot call for 1. Initially 1, we will take one count value, that means count equals to 0, sorry, so that means count equals to 0, and let's like this try. Initially take count equals to one count value or int count, and the value will be initially 0. Okay, and if you try DFS, then you call for 0 and make this count equals to 1, that means count plus count equals to 1. Now if you are at 0 using DFS, in this, that means concept of DFS, you call for neighbor, that the neighbor of 0 is 2 and 1, and you call for those neighbor which is unvisited, so 1 is unvisited, so you first call for 1. Okay, and 1 call for another neighbor 0 and 3, 0 is already visited, so 1 call for 3, so 3 will be visited. Now 3 will call for 1 and 2, but 1 is already visited, so 3 will call for 2, and 2 will be on 2 is unvisited, 2 is now visited. Okay, now 2 will call for 3 and 0, but 3 is already visited, 0 is already visited, so 3 will 2 will return the call because 2 attempted all the neighbor, 2 will return the call for 3, 3 is also attempted all the neighbor, so 3 will return its call for 1, 1 already attempted its neighbor 0 and 3, so 1 also return its call to the 0, and 0 is a try for 1, now 0 will try for another neighbor 2, but 2 is already visited, so he unable to call for 2, or now 0, the neighbor of all 0 is done, so 0 will return its final call. Okay, so the now your call is ended, but still your count value is 1, so your answer is 1 here, but this is not correct because your answer will be 3, or your answer must be 3. So where are you lagging in this problem? Here your count is 1. Why? Because you start from 0 only. Okay, you start you started from 0 only. Okay, if you start you if you started only from 0, then your answer will be 1, but correct answer is 3. So you will try to start from every node. Okay, now you started from 0, your answer is 1. Now you have a start, that means this is the starting. You have started from 0. Okay, so your count is still 1. Now you try to start from 1. Okay, if you try to start from 1, so but if you start only if that node is non-visited or unvisited. Okay, here 1 is already visited, so you cannot start from 1. Okay, so you try for a start from 2, so 2 is still 2 is already visited, so you cannot start from 2. Okay, now you try for 3, try from 3, but 3 is already visited, so you cannot start DFS call from 3. Now you will try for from 4. If you try from 4, then your call is that means your function call is starting, okay, or your function call will be a starting from 4 because 4 is still unvisited. So now your call will start and you visit, and if your call is started, then you increase count value and now your count value is 2. In first case, if you start from 0, then your count value is 1. Now another starting value is started from 4, so now your count value is 2. Now if 4 is already visited, now for call for neighbor 5 and 6, let's first call for neighbor 5 which is unvisited, so visit 5 and tick, then 5 attempt for 4 and 6, but 4 is already visited, so 5 try for 6. Okay, now 6 try for 4 and 5, but 4 and 5 is already visited, so call is your function call will be returned to 5 and 5 call return to 4 and 4 is try for another neighbor 6, but 6 is already busy, so now function call here is stopped. Okay, now you have started from 4, now try to start from 5. Okay, if you try from 5, then 5 is already visited, you cannot start from 5. Now you will try for to start from 6. 6 is already visited, so you cannot start from 6. Now you will try for 7 from 7. Okay, now if you try from 7, then you can see that this 7 is still unvisited, so you can start from 7. If you can start, then you will increase this count value. The number of times you start, number of times you increase count value. Okay, so now your count value is 3 and you will start from 7, so you will tick 7. Okay, and you call for neighbor, that means your neighbor is 8 which is still unvisited, so you call for 8. Now 8 call will be done and 8 is visited. Okay, now 8 try for neighbor 7, but 7 is already visited, so 8 call will not be done for 7, and 8 call will return to the 7. Now 8 call function will return to the 7 and 7. Now 7 have done or attempted all its neighbor which is all 8, so now this function call is done, and so 0 1 2 3 4 5 6, sorry, this 7 is also a starting purpose, or from 7 function call is a start, function call have started. So I make this tick showing that the function call was starting from 0 4 and 7, that means from 3 vertex or 3 vertex function call was starting. Okay, so the count value is 3 and which is now correct. So now we have to return this count value. So so I am trying to make this solution easy. Okay, for this purpose I have already, that means the step that I have done to solve this problem is purely DFS. Okay, now for this purpose let's first discuss or first try to solve this problem, and after if this problem will be solved, then again I will discuss this DFS approach. Okay, or let's say I am repeating this solution approach one more time. Okay, initially the count, there is one count whose value will be 0. Okay, initially, and at any instant if you able to start your function call, then you will increase this count value. Okay, let's you try to start from 0, that means you will try to start from every vertex. Okay, let's let's try. If you can start only if visited of that vertex is 0, okay. If the visited value of that vertex will be 0, then only you are able to start from that vertex, okay. Initially all the visited value of the vertex is 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, okay. Initially the default value of this visited array, okay, is 0, okay. You try to start, or you try to call dfs function, okay. dfs function call dfs function call from every vertex. Let's try from 0. Here 0 is already, that means 0 is non-visited, okay. If 0 is here, so you start from 0 and 0 is unvisited, so you can visit 0 and start. And if start from 0, then tick here, okay. This tick indicates that the starting function call is just, that means function call is starting from this vertex. If started from 0, then tick this 0. Now 0 will call for all its 0 will call for neighbor 1 and 2. Let's first call for 1. And if sorry, 0 only call for 1 only if 1 is unvisited. Here 1 is unvisited, so 0 call for 1, make this visited and tick this one. Now 1 try to call for 0 and 3, but 0 is already visited, so 1 cannot for 0. 1 call for 3, and here 3 is all unvisited, so make visited and tick this 3. Now 3 try for 1 and 2, but 1 is already visited, and 1 is already visited, so we cannot try for 1. Let's try for 2. 2 is unvisited, so 3 can try for 2, and 2 is ticked and make value of 2 is visited. Now 2 will try for all neighbors 0 and 3, but the value of 0 and 3 is 1, that means already 3 or 0 and 3 visited, so 2 cannot call for 0, not call for 3 also. So the function call returns towards the 3. Now 3 have done all its neighbor 2 and 1, so now function call returns to 1. Now 1 already have checked on for neighbor 3 and 0, so now function call will returns to 0, and 0 have attempted for one neighbor, that means 1. Now 0 try for another neighbor 2, but 0 cannot try 2 because 2 is already visited, so the function call of 0 will be returned from here, okay. That means on a starting, that means function call is a start from 0 is done. And sorry, if if any function call is starting from any vertex, then at that point count value will be increased, okay. So initially if the function call start from 0, so the count will be now from 0 to 1, okay. Sorry, I am unable to recall at that time. Now now dfs call a start try. Now you will try for to dfs start from 1. If you try from 1, then but 1 is already visited, so you cannot start from 1. Let's try for 2. 2 is already visited, so dfs call will not start from 2. Let's start from try to start from 3. 3 is already visited, so we cannot start from 3. Let us start from 4. Here 4 is unvisited, so okay, you can start from 4. So if you can start tick 4 here and increase this count value. Now count value is 2. This 2 indicates that second component is started, okay, start ho chuka hai. So make this 4 tick and well visited of 4 is 1. Now 4 call for 5 and 6. Let's first call for 5. Tick 5. 5 is unvisited, so make this visited. Now 5 try for 4 and 6, but 4 is already visited, so 5 cannot try for 4. 5 try for 6 and 6 is unvisited, so make this visited. Tick 6. Now 6 have ticked. Now 6 try for 4 and 5, that means never 4 and 5, but 4 and 5 both is visited, so 6 cannot call for 4. Now the calls of 6 will be returned to the 5. 5 have attempted all this number, the 4 call for 5 is now returned for 4, and 4 try for 4 4 have tried for 5. Now 4 try for 6, another number, but you cannot call 6 because 6 is already visited. Okay, so now the another function call is done. Now you can try to start from 5, but 5 is already visited. Now you try for 6, but 6 is already visited. Now you can try from 7. Okay. Now you can start from 7 because 7 is unvisited, so you can start from 7. If you can start now, increase the count value. Now count value is 3, so you tick 7, make 7 value 1. Now 7 try from neighbor, that means 8, and 8 unvisited, so make this visit and tick this. So you have done. Now 8 try for neighbor 7, but 7 is already visited, so 7, it cannot call for 7. Now this function call is also done. Now you will try for to start from 8, but you cannot start from it because 8 is already visited, so you cannot start from. That means here you can start only from 0, 4 and 7, so your final count value is 3, and this is your answer. This is correct answer because here number of connected components is 3. So this is the actual approach to solving this problem. Now let's coding this solution. Okay, coding this problem. So this is DFS call, so I will follow the same approach. Make visited array first and then try to start DFS call from every vertex. So what is the number of vertex? So the make is connected name as array. Okay, this is array, that means. And what is the number of vertex? So the number of vertex b equals to array dot length. Array dot length will give the number of vertex. Okay, now you have to make visited visited array int of size v. Okay, now what again? Next is we have to call DFS call for every nodes. Okay, now make one for loop I equals to 0, I is less than v plus. You have to and make DFS call only if and only if you can make DFS call if visited of that node, that means I equals to 0, then only you can call DFS function. Okay, and one more, for result purpose make count equals to 0 initial. Okay, here initially the count value is 0, and the times when you call any starting function DFS function, then you will increase function. Okay, so if visited equals to 0, that means now you can you can call DFS function. If you can call DFS function, then also increase count value. Okay, and if you if you call DFS function, then parameter will be pass like the I, which indicates the node at which this DFS function is starting. Okay, initially first array and then node value, that means I, and visited. Okay, so this is now make DFS function void DFS initially arrow int 2D array. Now node I denotes the node and one is visited array. If if you start any process or start to DFS call, then what's the next step? If you start, then make this visited and call for all its neighbor. Okay, that means same DFS. Then visited of node equals to 1 and call for all neighbor int. What is the neighbor in this question? Sorry, this is the not adjacency list, this is the adjacency matrix. So we have already discussed about adjacency matrix. If this is the adjacency matrix, okay, then this one, the one value indicates that there is node between this one. Okay, this, that means let's discuss. If this is like, this is the adjacency matrix, here this type, this will be the that means 0 1 2, 0 1 and 2. Here this is I and this will be your j. So if this value is 1, this value is 1, this matrix ij equals to 1, showing that there is direct edge between this I and this j, and 0 value indicate there is no edge between I and j. So this one indicates there is edge between I and j. So for this purpose we call child. If you are at this node, then what is their child? all the all the jth value in this, that means you follow across this node, this I value, you will follow all j, that means 0 to 0 to v minus 1, and the value where the value will be 1, showing that this is the child. Okay, okay. So int start from, so this purpose your I will be node, your I will be node, and your j will be starting from 0 to total node, starting from 0. J is what, less than, what is the total node? Array dot length will be the number of node. Okay, array dot length. Now j plus plus, and when you call, when will you call? Okay, if the value of, that means this is the actually the child, and this child is if unvisited, then only you can call. So if this is the child, so how you can say that this is child? If the value of array of this I and j equals to 1, if this ij array ij equals to 1, showing that this is the child, and also this should be, this should be what, unvisited. Okay, so here ij, where if in ij j is your child, so visited j will be 0. If your child and unvisited, then make dfs call, dfs call in dfs pass array. Now your what, your child is j and visited. So this will be your code. I think this will run, and you have to return this count value. I think this code should be run. Okay. Yes, I passed some test cases, like test for all test case. Okay, okay. So this is the code, and this code is passed. So okay, thank you. In next video, we will discuss about a space and time complexity. But if I include this, then this video will be much large. Okay.